Hello and welcome everyone to this Altair student webinar series. My name is Pritesh Shubham. I will be presenting the details about the basics of data science and its application. The session will begin with some insight about the data and discussion on what is data science and what is managed inside the data science. It will be followed by a short discussion on machine learning and artificial intelligence. And thereafter, a brief understanding of machine learning process will be done. Towards the end, we will have a session on Knowledge Studio where we will see how a machine learning predictive model can be created by using Altair's Knowledge Studio software. So let us begin our journey of understanding data and its science. We have heard the term data a lot many times in our life, but never realized what actually is data and how it can be effectively used to accomplish tasks that appears impossible to be done by a human. A simple definition of data is, it is unprocessed raw input, which means any input which we get from any source can be termed as data. A more formal definition of data is, it is a collection of facts such as numbers, words, measurements, observations, or descriptions of things. This implies that starting from our school grade to customer feedback, or product price to product quality measures, anything can be called as data. Let us have some more real example of data. Now, many of us have seen F1 car sports numerous times. This sports deals with so many independent variables that is beyond human capability to see these interactions anymore. One such insight that we can see many times on our television screen is how a team is in lead and poised well to win. And suddenly a graphic comes up that says only 5% entire tire life is left, but still 10% of lap is remaining. Now there is no way to determine such a great detail of insight without the data. So how are these decisions, predictions being made? From where these data are generated? The answer is over 300 sensors are generating enormous amount of data every fraction of a second. These sensors are placed in 4 main units, that is, around the engine, gearbox, power control module, and data logger unit. All the gathered data are then processed to gain the insight and make predictions. A Google Map is one of the most widely used mobile app which seems indispensable from our life. Whenever we travel, we most often tend to use this app to know the best path to reach the destination and the least amount of time needed to do that. Now, how does a Google Map application decide which is the most suitable road to follow, live traffic situation, and how much time it will take to reach to destination? These tasks seems impossible to be done by any human being. So how does a Google Map know these details? The answer is again data. The data which is generated from us and many like us. Google Map gathers the data generated from users' mobile to determine the latitude and longitude and the speed of the car and use all these information to predict the live traffic situation and advise us the best path to follow. Similar example is related to the cab booking service portal. Through the portal, we instantly know how far is the cab, the estimated fare to reach destination dependent on travel time. So question is again, how does an online portal knows such detail? An answer remains the same, the huge amount of data gathered from users' mobile and further processed to predict the outcome. There are many other numerous examples where we as a user play a significant role in generating data for companies and corporates. Facebook sees around 31 million messages exchanged every minute. YouTube have 500 videos uploaded every minute. Last year, billions of photos were shared online. So now you can realize that how everything around us is data. And what are we doing with such huge amount of data? Many corporates and institutions are using this in numerous ways. Some of these examples are already seen by us in earlier slides. Now question is, how do we use these data for leveraging its benefit? Here comes the data science into the picture. We use data science to get maximum benefit out of the gathered data. So now the next big question is, what is data science? A formal definition suggests that in the field of computer science, data science is a concept to unify statistics, data analysis, machine learning, and their related method in order to understand and analyze actual phenomena with data. This definition seems quite complex, so let us simplify the understanding. There are multiple domains in the field of computer science, which is coding, market research, and statistics. Every domain has its own features, and there is some area where these domains overlap. The subset of market research and programming creates a domain of data engineering. Statistics and market research forms the domain of data analysis. The most significant subset, which is formed by the overlapping zone of statistics and programming, is machine learning. This is the domain which is very trending recently due to its enormous potential in developing predictive analysis. We will discuss this in coming slide in detail. But looking further, another big aspect which came into the picture when all these three valuable subsets are overlapped to form a field of data science. So in simpler way, we can say that data science is the field which involves data engineering, data analysis, and machine learning. We can also say that data science or machine learning is helping to understand and analyze actual phenomena of real condition with data. Now, having understood that machine learning is pivotal in the field of data science, let us see more detail about machine learning. Machine learning term was first defined in the late years of 1950s by Arthur Samuel. According to his definition, machine learning is a field of science that gives computer the ability to learn without being explicitly programmed, which means without explicitly commanding the computer, called as machine, it can learn on its own based on the data. Machine learning is a data-driven approach which takes data as input and uses algorithm to determine the pattern of the data by correlating the independent variable with the target data, and as a result develops a predictive model which can be used for forecasting the future based on the past data. There are a variety of machine learning algorithms and each has its own significance and some limitations. Regression, classification, deep learning, and neural network are examples of some of the most widely used algorithms. Along with machine learning, there is another similar domain that is known as artificial intelligence. Many a time, these two terms are often confused. To have a clear distinction, we can see artificial intelligence as a bigger umbrella, which has ability to learn and reason similar to humans. Thereafter, machine learning can be seen as the subset of artificial intelligence. Machine learning process needs instruction in the form of program. However, it does not need to be explicitly programmed. Deep learning can be seen as further subset of machine learning, which uses artificial neural networks and learned from the vast amount of data. Having seen several details about data science, machine learning, artificial intelligence, and deep learning, let us move deeper and understand briefly the machine learning process. There are 7 different stages in the machine learning process, and most of them revolve around data. The process begins with data acquisition. In this process, information is gathered from a variety of sources. These can be in the form of numeric values as well as in the textual form. Data curation follows data acquisition, which involves cleaning up and correcting the raw data which was obtained in earlier stage. This stage involves data analysis, data cleaning, and data transformation. Altair's Monarch software is one such software that is best suited for the data curation process. Data exploration is the third stage of machine learning process. In this process, the clean data is further explored to check for the variance within it by the help of data analysis technique. In the fourth stage, machine learning model is created. In this process, the algorithms are developed which can process the curated data and formulate the mathematical equation that is best fit for the data set. Once the algorithm is created, data is then further bifurcated into training data and testing data. By considering the training data set, training of the machine learning model is performed in the fifth stage. In this process, the algorithm learns from the data and correlates the dependent and independent variable to determine the best fit model. Thereafter, in the sixth stage, model evaluation is done. Model evaluation is a method of checking the performance of the trained model. The testing dataset is used for the evaluation of the model. The final stage of machine learning is prediction stage. It is the process of forecasting the likelihood of the outcome through the trained algorithm on the historical dataset. All these 7 stages are followed whenever any predictive analysis is to be done on the gathered data by using machine learning process. Having said so many things about machine learning and its process, let us have some hands-on session where we can use a dataset for creating a predictive model. Altair's Knowledge Studio is the most advanced and user-friendly software which can create a machine learning predictive model with just few simple clicks. Altair Knowledge Studio is the data mining and predictive analytics software tool. Instead of writing numerous lines of codes, this software's graphical interface enables user to select the options from the list of menu and develop a robust machine learning model that can be implemented in a real-time condition. Knowledge Studio also enables advanced analytics to be built and deploy predictive models using repeatable workflow. The Knowledge Studio features includes data preparation and profiling, variable selection, decision tree analysis, building predictive models, principal component analysis, market basket analysis, and many more. This image shows the graphical interface of Knowledge Studio software. It has multiple tools which can be selected from the menu bar. Towards the left extreme, we have Project Explorer, which shows list of all the projects that have been undertaken till now. The Workflow Process panel is the place from where various options are picked for the model creation. Now let us consider a real data obtained from the sensors of an electric motor and use Knowledge Studio for creating a machine learning predictive analysis. So the problem is to predict torque by considering various parameters of electric motor. The algorithm for this problem, which we will consider, is linear regression. 12 different variables are considered to correlate the target variable, which is motor torque. So let us now explore Altair's Knowledge Studio software. So this is Altair's Knowledge Studio platform, which we are going to use for creating the predictive analysis. Now to create a new project for machine learning, we have to select the option from the top of the menu by the help of left click of the mouse and give the name. For the time being, let us consider the name as Motor Torque Predictor. Once the project is created, you will see the blank canvas where all the activities can be performed. The first step into the Knowledge Studio canvas is to import the required data. The data which is generated by electrical motor sensor and compiled in a systematic form. To import data into the canvas, the steps to be followed are: from the Workflow panel, inside the Connect tab, select File Import option and drag it into the canvas like this. Then double-click on this Import File node and define the path from where data need to be imported. It will take a few seconds to process the imported data. Once the process is completed successfully, you will see a green dot in the lower right corner of the node, and a new node of imported data will be created. You can also drag the node and relocate it to your desired alignment. You have to press on the node and drag it wherever you need that. After data import, the data exploration stage is followed. Now to do this, double-click on the imported data node and select the various options to explore the data. Inside the Data tab, you can also visualize the data which you have imported. It will only show first 100 rows by default. So if you want to see more, what you have to do is you have to press Show More, and then another set of 100 rows will be visible. For further data exploration, the statistical calculation on the imported data can also be performed. For this, you need to go inside the Overview report, then select Option from the above menu list and choose options such as Basic Measures, Central Tendencies, Measure of dispersants, etc., which you need for calculation, and then press Calculate All. So this will help you to explore the data and see what type of input you need to consider. Once the data is deemed fit, it is then bifurcated into two parts, which is the training dataset and testing dataset. Now to perform this bifurcation, go to the Manipulation tab, select Partition option and drag it into the canvas, and then connect the imported data to the partition node by dragging the arrow in this way. Once that has been done, double-click on the partition node and press Add. First partition will be named as Training Data. We can divide the data either by using a record count or by using % of total data. The latter is more preferred. So let us select the radio button of the % of total and then feed the value as 70%. In general, we consider 70:30 or 60:40 ratio for data partition. For this problem, we will be considering 70% of the data used for training of the machine learning model, and then 30% of the remaining data will be used for the testing process. After defining the training data, once again press the Add button and this time name the data as testing data and feed the value as 30% of the total, and then press Run button to execute the partition. Once partition is done, you will have two separate nodes. One is training data and other is testing data. Once again, drag the node to arrange them. We can also use Auto Arrange option to automatically arrange in the most suitable manner. This option can be selected from the top menu. After the partition, the model needs to be selected for creating the predictive analysis. This can be done by going into the Model tab and selecting the desired model. For our problem, we will be considering the linear regression model for the analysis. So we will drag the linear regression model into the canvas and connect with the training data. Now thereafter, double-click on the regression model and press Next. Then select the dependent variable as Talk from the list. And also select the required independent variables from the list by either double-clicking on them or selecting all to get imported by the arrow button. Then press Run button to execute the model training. This process will take a few seconds to allow the model use the training data and correlate the dependent variable with the independent variables. Once the process is done, you will again see a green circle appear towards the lower right corner. This confirms that training has been successful. You can also double-click and check the performance of the model training. For the linear regression, the success of model is measured by the value of variance explained. The maximum will be 1 and least will be 0. The model training is considered to be the best if it shows the variance close to 1. For the problem which we have considered, we can see 99% variance is explained by the model which is an exceptional result. Now, many more details can be further seen inside the output view command, such as currently selected sequence as well as the sequence. Inside the sequence tab, you can go down and see the formula which is used for predicting the torque based on other independent variable data. After satisfactory results are obtained from the model training, it is now the time to evaluate the model performance with the untrained data, which is the testing data set. Now to do that, we have to go inside the Evaluate tab and select Model Validation and drag it into the canvas. Once this model validation node is placed inside the canvas, we have to link this node with linear regression model and testing dataset. Thereafter, double-click on the model validator and press Next twice and run the validator. The model validator will let us know how well a machine learning model is performing for predicting the unknown data. Now to check the model performance, double-click on the newly created testing node and go inside the Data tab. You have many options which is presented in the tabulated manner. You can see all the independent variables and dependent variables presented in the tabulated manner. In the same place, we can see the comparison of the result. Since our aim was to predict the torque, we have to go into the column of the torque prediction and see how well it is performed by checking the predicted values. The next to this column, we can also see the torque error column. This column shows how much variation is there in the prediction. The result shows marginal error is present in the prediction, which confirms model is performing very well. Once we found model performing satisfactorily, we can use this model to implement into the real system to use it further. The program can also be generated by using Action tab. So this is how we create machine learning predictive analysis by using Knowledge Studio. You can see how simple it is to create a predictive analysis by using Knowledge Studio software. And as I have mentioned earlier, it is very user-friendly and the graphical user interface help us to understand and visualize the whole flow of the machine learning process. So let us conclude our learning for this session. So we have understood that data science is the new technique that serves as umbrella to data creation, manipulation, predictive analysis and research. The data and capability to extract useful insight from data must be considered a key strategic asset. The gained insight from data can solve business and engineering problems. And in this digital age, it's very important to groom future engineers and managers to the data science technique. That's it from my side. Thank you for joining the session. And if you have any questions in your mind, I will be happy to answer them.